Greetings, detectives. It's Mrs. McKay, and we are on our last learning target clue for Case 3 sequence scenarios. Our learning target clue says I can use the constant ratio, so I'd like you to write the word ratio, to identify the geometric means. Last time we talked about arithmetic means, now we're talking about geometric means of a geometric sequence. So I can use the constant ratio to identify the geometric means of a geometric sequence. Let's go ahead and quickly look at our review. Let's remember what a constant ratio is. A constant ratio is used in a geometric sequence, which is a little bit different than an arithmetic sequence. Arithmetic sequences, we add or subtract a constant difference. In geometric sequences, we multiply by a constant ratio. So here would be an example. 2, 4, 8, 16, 32. And you can see that our constant ratio is to multiply by 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2, just put a little times 2, is 16, 16 times 2 is 32. So that's our constant ratio. It's the number that we multiply by to get the next term. And we talked about arithmetic means, and arithmetic means in our last lesson were all about finding those missing terms, and we found that we could think about the constant difference. If we knew what the first term was and we knew what the constant difference was, we usually could figure out any missing term. And we also talked about recursive equations, and that's really what we're doing when we are figuring out those arithmetic means. Once we know the constant difference, then we just use the recursive formula or the recursive rule, recursive equation that basically says we add or subtract to that. And we're going to do the same thing with constant ratios, except we're going to multiply. And then the explicit formula we found could help us find the constant difference, and I'm wondering if we can use that explicit formula or equation to also figure out our constant ratios when we're looking for geometric means. So now let's go ahead and get started by looking at this first set of geometric sequences. So here we have find the missing terms of the geometric sequences. So our first one, we have 3 terms. The first term is 3, the second term we don't know, and the third term is 12. Now remember, a geometric sequence is going to tell us not what we're going to add or subtract, but what are we going to multiply or divide by. So think about what the constant ratio would be to get from here to here and then from here to here. What do you think that constant ratio is? Did you figure out that it's actually times 2? Because 3 times 2 is 6, and 6 times 2 is 12. Why don't you go ahead and take a minute and tell me, write, and explain how you figured out what that missing term was. Take a minute and just write that out. Now, some of you may have used our traditional guess and check, where you just started trying out some things. And guess and check works. You can usually make it work when you've got one missing term. But it starts to get a little bit more tricky when you get more missing terms, especially as your numbers get so large. So take a look at this next one. We have 4 terms. The first term is a 7. The second term is 875. And we've got 2 missing terms. How are you going to figure out what the missing term is? is there a way that you could figure out what the constant ratio is? If you knew what the constant ratio was, you might be able to then just use that and multiply across. How are you going to figure out, how are we going to figure out what that constant ratio is? Give us your best shot. What do you think the constant ratio is? Try it out and see. So what did you do? How did you figure out what the constant ratio is? Do you remember in arithmetic means, I always would draw a line to represent the constant difference? Well, I've done the same thing here. I've written 3 lines that would represent what I would multiply 7 by to get the second term, and then what that same number that I would multiply that second term by to get the third term, and then I would multiply the third term by that same constant ratio to get 875. So I think I could write it like this. I could say that I'm going to multiply 7, which is my first term, times the constant ratio times the constant ratio times the constant ratio. So I multiply it by the constant ratio 3 times, and I'm going to get 875. So if I have 7 times r times r times r, that's really just r cubed, isn't it? So 7r cubed equals 875. How can I solve for r? Well, I could first divide by 7 on both sides. I'm going to pull up my calculator for this. And I'm going to say that 875 divided by 7 equals 125. So that means that r cubed equals 125, which means that some number times itself 3 times is equal to 125. Now you might be able to figure that out. You might be able to say, what number times itself 3 times will give me 125? Not what number times 3, but what number times itself. But if that gets a little bit too confusing and complicated for you, if you have a calculator that has these different root equations, this is the square root. We don't want the square root. We want the cubed root. Or we could even use this x root of y here. And I'm going to show you how you would do that. So you type in your number, 125. There's 125. I'm going to click that button, and then I'm going to tell it how many times, what root I'm going to find. So this is the r cubed, so I'm going to type in a 3. So that means I want to find what number times itself 3 times is equal to the 125. When I say equals, I get 4.99999. And I'm going to try this one more time because I really want it to be 5. So I'm going to say 125 3 equals, well, it's just determined to give me 4.999. It's really 5. And I know that because I can say, clear, 5 times 5. Oops. Always helps if I do this right. 5 times 5 equals 125. Now I wonder why it was doing that to me. What if I did 125 and I did the cubed root of it? Still gives me 4.999. So it seems to want to tell me that it's 4.999. When I round it, it's 5. Not sure why it's doing that. Well, but regardless, we've figured out that the constant ratio, r, equals 5. The constant ratio equals 5. So now all I have to do is I just have to multiply my constant ratio by each term using what I know about the recursive equation. So 7 times 5 is 35. And then I take 35 times 5, need my calculator again. $35 times 5 that's 175. And then I better just double check to make sure that 175 times 5 is equal to 875, and it is. So I can say that my third term is 175. So I've got 7 times 5 is 35. 35 times 5 is 175, and 175 times 5 is 875. So let's use that same idea and see if we can figure out what our constant ratio is for this next one. We started with 6 and we end up with 96. So what would you do first? Maybe you would figure out how many constant ratios you are going to need to multiply by. So think of these as r's. R times R times R times R, right? So that's r to the 4th. And if we multiply 6 times r times r times r times r, we should have 6 times r to the 4th power equals 96. And then, of course, if I'm going to solve for r, I have to get it by itself. So I'm going to make the 6 go away by dividing by 6. And when I have 96 divided by 6, I get 16. So that means r to the 4th equals 16. So what number times itself 4 times gives me 16? Now I could go in and plug that into my calculator again, but I think I know what it is. It's going to be 2. My constant difference is going to be times 2. Times 2. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. And 48 times 2 is 96. So there are some ways to find those geometric means. One way is to do just what we did. What we're looking at, the number of constant ratios, and whatever that number of the number of constant ratios are, we know that we have to find that. We have to find, first of all, we have to find the constant ratio. So that's important. So write that down. Find the constant ratio. And then how you go about finding it, you can do it several ways. You can do exactly what I did, draw it out, and just count the constant ratios. Count how many they are and know that it's multiplied times itself, that it's going to be an exponent, right? In this situation, we said it was the first term times r to the number that we did, so the number that we counted out, right? And we could and we would say this is the last term, right? That's what it's equal to, the last term. So it's just kind of intuitively figuring it out. If we wanted to come up with an explicit an explicit equation, well, we could think about what we've learned about explicit equations, and what we've said is that f of n is equal to the first term, a1, times r to the n minus 1 exponent. That's what we figured out in previous lessons. So let's see if that would work for us on this one right here. We said that, so what we would want to do is we would say, well, we already know what f of 5 is, right? We said f of 5 is equal to the first term, which is 6, times r to the n, which is 5, minus 1, so r to the 4th. And look at that. F of 5 is equal to 6 times r to the 4th power. Well, we know what f of 5 is. We know that it's 96. So then we can write here 96 equals 6r to the 4th. And then we can just solve for the ratio. We can just solve for the common ratio, and once we know what the common ratio is, then we just fill in our missing terms. Okay? So the only thing really that's different about geometric sequences, different than what they are with arithmetic sequences, of course, the obvious that we're dealing with multiplying ratios by themselves instead of adding them. We are multiplying, so we're going to end up with these exponents. But the other thing is, my question is, are the missing terms the only answers? Are the ones that we found right here, 12, 24, and 48, are those the only possible answers? Are those the only possible answers that we could get here and still end up with a common ratio, a constant ratio, and start with 6, end with 96, maybe have different numbers in the middle? Think about that for a minute, and then tell me what you think. The reason I asked that question is because if I say r squared equals 4, what is r equal to? What is r equal to? Well, what number times itself gives me 4? What's the square root of 4? The square root of r squared is r. The square root of 4 is 2. Most people immediately say, oh yeah, 2 times 2 is equal to 4, so r must be 2. But is there another number that when you multiply it by itself, you get 4? Think about it. What's that other number? That's right. The other number is negative 2. Because when I multiply negative 2 times negative 2, I get a positive 4. So, as we think about this, if we say that r squared could either be a positive version or a negative version, meaning r could also be negative 2, then perhaps we would end up with something different. What if our constant ratio was a negative 2 instead of a positive 2? What would happen if we did that? Well, we would do 6 times negative 2 is a negative 12. Negative 12 times a negative 2 is a positive 24. 24 times a negative 2 would give me negative 48. And negative 48 times a negative 2 would give me a positive 96. So actually, there are, in this situation, there is another set of numbers that we could use to fill in for these missing terms. Negative 12, 24, negative 48, with a different constant ratio. Why do you think that's so? Why do you think that's so? Tell me why. Now, let's go ahead and look at this last problem and see if we can figure this out. We've got our first term is 1, our last term is the sixth term. So actually, our first term is 4, our sixth term is 972. And the question is, what is the constant ratio, and can you fill in these boxes with the missing terms? See if you can figure it out. As you know, I like to draw my lines just to figure out what the constant ratio is. But if you wanted to use our explicit equation, you could do that. You could have done f of 6 is 972, and it's 4 times r to the n minus 1, which would be 6 minus 1, which is to the 5th power. I like to just go ahead and write it out so I can see my r's. I've got 1, 2, 3, 4, 5. So that means I'm going to multiply 4 times r to the 5th power, and that's going to equal 972. And that's because I take 4 and I multiply it by r, and then I multiply it by r, and then I multiply by r, and I multiply by r, I multiply by r 5 times. So 4 times r to the 5th equals 972. I'm going to divide by 4 to see what I get, and I should get r to the 5th equals 972 divided by 4 equals 243. Let me make sure that I did that right. 972 divided by 4 equals 243. So I'm going to write right here 243. Now I have to figure out what number times itself 5 times is equal to 243. Well, that's just a little bit beyond my capabilities. So I'm going to take my 243. I'm going to hit my nth root sign, and I'm going to say I want to know the 5th root, and then I'm going to say equal, and it's 3. So it says that r must be 3. So that means my constant ratio is 3. So I'm going to write 3 here. So 4 times 3 is 12, and 12 times 3 is 36. 36 times 3 is 108, I believe. 3 times 6 is 18, carry the 1. 3 times 3 is 9, plus 1 is 10. So 108, and 108 times 3 is 324. And 324 times 3, 3 times 4 is 12, carry the 1, 3 times 2 is 6, plus 1 is 7, 972. So there, I've just figured it out. So the question on this one is, are the missing terms the only answers? Could we have some negative numbers in here? Would it work? Could these be negative 3's instead? Let's see. 4 times negative 3 would be negative 12. Negative 12 times negative 3 would be positive 36. 36 times a negative 3 would be negative 108. Negative 108 times a negative 3 would be a positive 324. 324 times a negative 3 would be a negative 979. So in this situation, I can't change my constant ratio. I can't use a negative 3. And why is that? Why can't we do it? Well, when we end up multiplying everything, we don't come up with our end term, 972. We come up with a negative version. So the question is, how can you tell if there will be more than one solution for the geometric means? Well, let's look back and see. In this one, could we have had a -2? Could we have said 3 times -2 gives me -6, and -6 times -2 gives me +12? Yes, I can have either 2 or -2, can't I? All right? On this one, could I do it? 7 times, if I made these be -5s, 7 times -5 would be -35. -35 times -5 would be a positive 175. 175 times -5 would be a -875. No, it won't work. Will not work. Okay? That one doesn't work. This one we already tried and we said, yes, it does work. And the last one that we did down here, it was no, it didn't work. So how can we tell whether we can have more than one geometric mean? Because our ratio can be either a positive or a negative. How can we tell? Look and see if you can tell me how you would know. And then go ahead and write it down here. How can you tell if there will be more than one solution for the geometric means? See what you came up with. Did you notice something? Did you notice that on the starred ones, the ones that you could have a positive or a negative constant ratio, that you had one missing term here, you had 3 missing terms here, and on these that it didn't work, you had 2 missing terms here and 1, 2, 3, 4 missing terms there. Do you see the difference? What do you need to have? What type, how many missing terms do you need to have to be able to say, yes, it can be a positive or a negative? I think you might see it. You have to have an odd number of missing terms or geometric means. When you have an odd number, then it goes positive, negative, positive, negative, positive, negative. If you have a even number, you end up with a negative. Do you see that? So make sure that you've written something about that. And then I think we're done with sequence scenarios. We've just talked about geometric means, and we are now completely finished. So make sure that you write down a key idea down at the bottom, and I will see you in class.